Hello everybody. We're going to start off by talking a little bit about the programming model, and I'll dig into each piece of that and explain what that implies and what you can do in that part of it. So to start with, the programming model for XNA is a bit different than your traditional Windows programming model. So you're not dealing with forms-based programming. You're not dealing with the massive number of events that you would typically have to work with, whether in web forms or Windows forms. We do generate some events, but primarily it's a different model. So to get started, I've got a diagram here on the screen, and we're going to talk a little bit about the initialize method. So when your game first spins up, the initialize method is going to get called, and this allows your game to do anything that it needs to do before the game actually starts running and the players are able to interact with it. So typically this is where you're going to do stuff like maybe query for any required services. If your game uses the accelerometer, this would be where you would potentially initially turn the accelerometer on. If you're using GPS in your game, that kind of stuff. So it's also used for initializing any components you have. And we'll talk a little bit more about game components a little later in this talk, but essentially the initialize method is where you get everything ready so that your game can consume it and start playing. Here's an example of what your initialize method is typically going to look like, and as you can see, I've added a few dummy methods in there. So we're initializing the accelerometer. We're also turning on gesture support. I'll talk a little bit more about gestures later in the talk. Making a call out to a WCF service to set up our global high scoreboard, make sure we've got communication with that. And so these are some of the things that you would typically do in that method. Once initialize gets fired, the next thing up is the load content method. This gets called once per game, and this is the place where you load all of the content. I know that sounds redundant, for your game. And this is anything ranging from art assets, Sprite Fonts, which we talked a little bit about in the previous webinar. Sprite Fonts are how you actually display text on screen, and they're actually really just graphics. You're not putting text on the screen in the traditional sense so much as images of text. And so when you create a Sprite Font as part of your project, that's going to get loaded up during the load content phase of your game initializing. This is also where you could load in some 3D models, music in the form of MP3 files, sound effects in the form of WAV files, any custom XML content, and other things. This is just a short list. And so here we have an example of the load content method as you would find in the basic template that you get when you create a new XNA game. By default, they go ahead and set up the Spritebatch for you. So we talked a little bit about the Spritebatch in the previous webinar, and I'll dig into that again as well in this one. So we've also got some sample methods here where we're loading up Sprite Fonts, and you can certainly make all the individual calls right from within load content, but if you're doing a lot of loading up various Sprite Fonts or music or that sort of thing, then perhaps you would want to break it out into methods like this. So once we're done with load content, that's where we enter what we refer to as our game loop. Now, the game loop consists primarily of the two methods that you see, the update and the draw. Now, I'm going to talk a little bit about each of those and then talk about how they relate to each other and the game loop as a whole. So the update method is typically where you're going to do stuff like running logic that maybe updates the state of your game world. It checks for any collisions, whether it's between the character that you're controlling and a wall, or between a missile and an enemy, or your spaceship and an asteroid, depending on the type of game you're making. Your logic processing, you're checking for collisions, you're gathering input from the player, so whether they're using the keyboard or a gamepad, and granted this isn't strictly for phone, but the concept applies either way. So a keyboard, a gamepad, the touch screen, any of those would be considered input. And so you would check for that during the update method. Any AI calculations, maybe the enemies in your game are fairly smart or not. And so they do some basic AI calculations to figure out the easiest way to get to you. So if they've got to do pathfinding to get around a wall, or maybe you've got a system of waypoints for a tower defense type game where the bad guys all follow a specific path and you want to make sure they stay on that path, then your AI calculations are going to determine things like where are they currently, where are they headed, how do they get there. So all of that happens in the update method. Kicking off any audio. So maybe you have some sound effects like explosions or that sort of thing that need to be fired at critical points within the game. This too would happen in the update method. State machines, which are a type of AI that help with making decisions about the world that your game exists in. Screen managers, these would also take place in the update method. So by screen manager, that's not actually a built-in part of XNA, but that's something that you would typically develop if you have a fairly complex game that has multiple screens or multiple levels. Then you would want to have some type of screen manager that controls what the player is currently seeing at any given point. Maybe they're on level 3, or maybe they've hit the back button to pull up an options screen. And so a screen manager would handle the transitions between levels and between one screen to the next, and preserve any information about the state of the game while you're on one screen or another. And so that would all get processed as well. So here's a little example code for the update method, and you can see it's pretty sparse as it stands right here. We've got a little bit of stubbed out methods to check for player input, perform enemy AI, and then update the world. And so you might have another one in here that says move player, for example. So if as a result of my dragging my finger to the left, I need to increment or decrement rather the X position of my model, and then we would do that here. And then of course we get to the draw method. This is where we take all of that state information that we just worked with, whether it's the state of the world, the position of our enemies, whether or not they've been hit by a rocket. We take all of that information and we use it to draw whatever needs to be drawn on screen. So perhaps you just recognized a collision within your update method. So a rocket hit a target, then you want to kick off an explosion animation, which would actually happen in the draw method. You want to move your character across the screen. Each time you pass through the draw method, you're updating his position in update and then actually drawing him in the new position in draw. And of course, there's the concept of game time, which we'll dig into a little bit more. Game time is used to control, among other things, it's used to control the speed of your animations. So for those of you that have been gaming for a while, back in the good old days when processing power of desktop machines was increasing at a ridiculous rate of speed, it was very possible that you could buy a game for one computer, and a year later when you upgrade, that game would be nearly unplayable because the CPU was so much faster on the new computer, and the game didn't really take into account the new processor. So when you played it, everything was running at 10 or 100 times the speed. And so it would really lend itself to a very negative gameplay experience for the players. So game time allows you to base things like your animations and clocks and stuff like that within the game on actual time that has elapsed versus just running off the raw speed of the processor. So it gives a much more consistent gameplay experience across the board, whether you're running on an Xbox 360 or on a phone, or you're running on a PC and you upgrade your PC, you're still going to have basically the same gameplay experience, and everyone else will too. And then screen managers, which we talked about a little bit in the update method, these will of course take the information that you updated and then figure out which screen it needs to draw and go from there. So here we have a sample of the draw method. You've got at the very beginning here, the graphics device.clear, that's something that they include in the starting template of a XNA project that you get. In this case, it's setting the background screen to cornflower blue. There's a lot of different colors to choose from, of course. You want to clear the screen each time you pass through draw before you start drawing everything else. Otherwise, it's going to be a mess. So if you're updating the position of something every time you pass through draw and you don't clear the screen first, then what you're going to get is this weird ghost effect as your objects move across the screen and the old ones aren't being deleted. Or not deleted so much as just cleared out with the new one drawn. And so we've got a little bit of sample code here as well where we draw the background. It's important to remember when you're working in XNA with your Spritebatch that the order in which you tell something to draw is very important. So if the last thing you draw is your background, for example, it's the only thing you'll see. So you need to draw your background, then you need to draw your hero and your enemies, and then maybe you would draw the various screen effects. Maybe it's raining, maybe it's snowing, maybe there's fog, and so you would want to draw that after you draw the other stuff so that it obscures whatever it is you want to obscure. So the order of drawing things is very important. Now, one thing that I didn't mention up to this point that I do want to highlight is that you may have noticed, and I'm going to actually jump back a bit, at the end of the update method there's a call to base.update, and there's also at the end of the draw method there's a call to base.draw. And we'll get into components in a little bit, but I did want to highlight this part. Those two calls, base.update and base.draw, will fire off any code in your components. And so components, of course, are a way to isolate specific functionality. And so this makes sure that once the main update or the main draw is performed, base.update and base.draw go out and call the respective update and draw methods of any components that you've registered as part of your game. And so that's an important thing to keep in mind as well. So now that we've talked a little bit about the update method and a little bit about the draw method, I want to talk a little more about the game loop. So at this point, you're in the game loop. You've initialized any services, whether they're hardware services or remote services. You've loaded your graphical content, and now you've entered the game loop. And so each pass through the game loop is effectively a call to the update method and a call to the draw method. And this is what you refer to as a frame. So when you hear people talking about frames per second, that's a pass through this loop. And so when you hear people talking about they've got a new 3D graphics card and they're getting 90 frames per second on their favorite first-person shooter, that's literally 90 passes through this loop, update, draw, per second, which is pretty fast. You're typically not going to see, well, you won't see those speeds on the Xbox. The Xbox is fixed at 60 frames per second. Windows Phone is fixed at 30 frames per second. So while it is possible on PC to get some pretty ridiculous frame rates, you're actually locked in to a consistent frame rate on the 360 and on Windows Phone. So after your game is effectively over, you've either won the game or you've been killed and you've decided to exit, you're going to drop out of the game loop at this point. And the next thing that fires is the unload content method. And this is where all of the various stuff that you loaded up in the beginning gets unloaded. And so it's typically a good practice, of course, to kill anything that you had brought into memory at this point, whether it's art or music, any sound effects and stuff that you had playing or background music that was going. You want to make sure to kill that off and free up the memory. And then the last thing you do from that point, well, let's look at the source, sorry. So here's the method, of course, that gets generated for that. And so anything that you would want to unload would go in here. And then finally, there is not an actual end method. Once you pass through unload content, the game's over. So there's nothing specific that you need to do on there. Now, having said that, there are cases where perhaps, especially on the phone, there are cases where maybe your game gets interrupted or maybe you need to suspend your game. So since you're running on a phone, maybe you get a phone call, for example. And so the way to handle that is that your game can actually fire an event that you can catch and say, oh, my game's about to be ended not by my choice, but because there's a significant event coming in, like a phone call or something like that. And you can capture that event and then use that brief instance to take any game state data that you have and write it out to isolated storage. Now, we'll talk a little bit more about isolated storage in a moment, but essentially, on the phone, you don't have access to just write stuff out willy-nilly to the file system. What they give you is isolated storage, and that allows you to create files within a specific isolated area that is specific to your application. And so that way you can save out high scores. You can save, if you're doing a race game, you could save track times. You could, if your game's getting booted out in the middle of a level, you could save state information. And so that way, a phone call comes in, you accept the phone call, it dumps the state of your game out to isolated storage, you take the call, and then when you hang up and you launch back into your game, the first thing as a developer you're going to want to do is check and see, is there currently any game state information sitting out in isolated storage? And if it is, then let's load it up and give the player the option to resume the game where they left off, or maybe they just want to start over. But that's just part of the gameplay experience that, as a developer, you would provide. So continuing on with the XNA programming model, there's a few key classes and objects I definitely want to highlight. The first of those is the graphics device manager. This gives you an abstraction to the actual graphical hardware. So in the good old days of game development, programmers had to write a lot of really nasty code in order to push the graphics cards to do stuff for them. One of the great things about XNA is that gets abstracted out, and so you get a graphics device manager, which means you get a graphics object that allows you to do stuff, and it's much simpler to work with than having to talk directly to the graphics card itself. One of the things that you do, of course, is when you create a sprite batch, you're effectively getting a handle to that graphics device, which is, in the case of the phone, it's the graphics chip on your phone. In a PC, it could be a card, etc. So with the sprite batch, and we talked about the sprite batch a little bit in the previous webinar, but the sprite batch allows you to take calls that you would normally pass to your graphics card and bundle them up. So if you've got a game that you're working on that has a lot going on the screen at once, so maybe a Space Invaders type game is a good example, where you might have 30 or 40 aliens on screen, and they're all moving, they've all got their own little animations, and you've got your tank at the bottom, and you've got missiles dropping and flying saucers going by, and there's a lot of stuff going on the screen. What you do not want to do is try to make a separate call to the graphics card for every single item that you need to update every frame. It'll kill your frame rate. Your game will run incredibly slow to the point of being pretty much unplayable. So what you do is you open up a sprite batch, and we'll take a look at some code in a little bit that shows this, but effectively you start your sprite batch, and then you make all your draw calls that you want to make in that open sprite batch. And now none of them are going out at this point. You're making the calls, spritebatch.draw, you're passing in the asset name for the image you want to draw, you're passing in positional data, X and Y coordinates, if you're doing any kind of rotation or anything like that. And then once you've made all your calls, then you close the sprite batch. And at that point, they all get bundled up together and sent to the graphics card. So one call for 30, 40, 50, 60 items as opposed to 60 different calls. It's much more efficient, much smoother performance. So in addition to the sprite batch, we have the Sprite Font, which we talked about a little bit in the last webinar as well. This is how you display text on screen. Now, a lot of times I hear people get confused, especially on the phone, where they ask, well, do the new cut and paste features work in XNA? Can I grab a piece of text out of a game and paste it in somewhere else? And the answer, unfortunately, is no, because you're not actually displaying text in that sense of the word. You do have words on screen, kind of like we do now, but each character in a sprite font is a separate individual image. And so when you create a sprite font, you're actually basically creating an XML file that gets processed at build time. And that XML file tells your project, I want to use this font, maybe it's Arial, maybe it's Verdana, at a specific size, and I'm going to take that font, and I only want to use these characters, start here, end here, and I'm going to use those characters in my game. And so when you want to draw some text on screen, there's a Spritebatch, instead of Spritebatch.draw, there's Spritebatch.drawString. You pass in the string, you pass in the sprite font you want to use, and again, some positional data and a color, and it takes that string and it goes through and picks out the image for every letter in that string and draws it on the screen. So that's effectively how a sprite font works. One note worth mentioning about sprite fonts: just because you have a font on your computer does not mean you can use it in your game. And this is a big deal I've seen people run into as well. There's a lot of really cool fonts out on the internet. There's a lot of really interesting fonts that even come with Windows. But a lot of them you're going to need permission to use in your game. So a lot of websites out there that either sell fonts or have free fonts, they have very specific terms of use around them. And I've seen games get pulled out of the marketplace, out of Xbox Live indie games, because somebody who owned a font saw their font in a game and went nuts and threatened to sue. So it's definitely, make sure you have permission to use it, or make sure you download the redistributable font pack from Microsoft. And so that's a collection of, I think, 7 or 8 fonts that you can get off of the Create site, create.msdn.com, and you can download that, and those are free for you to use. Now, one thing to understand, you're not actually pushing the font itself out to the phone, okay? When you build your XNA project, it's going to read that Sprite Font XML, it's going to read the font file itself, the actual font file, and then it's going to generate a bitmap of the characters that are being used in that font. And it's that bitmap that gets packaged into your game. And so when XNA needs to generate a sprite font, it's reading that bitmap, and this is just one image with a bunch of letters and numbers on it. It's going to read that bitmap, and it's going to slice and dice it in memory so that it knows that, well, if I need a capital C, then I need to grab the third character from the left on the top row. That's capital C. And so it's one single bitmap that's being used as an asset in your game. So when you push your game out to the phone or the Xbox 360, you're not actually pushing a true type font in that sense of the word out to the device. It's strictly just a representation of the characters in the font. Okay, so game components. I mentioned earlier that we would talk about those, and the concept behind game components and also drawable game components is pretty straightforward. If you want to isolate some specific functionality, which is typically a good practice in your game, then you want to create a game component. And so the way you would do this is, it's just like adding an image or adding a sprite font. You're going to go in your solution, you're going to right click and add new item, and one of the choices that you have is a game component. And we'll dig into this a little deeper when I actually open up Visual Studio. But the game component works just like your game class. You've still got a draw method, an update method, you've got an initialize method, and those all get called from the respective methods in the game class. So when the initialize method in your game class first fires up, the very last line in there is base.initialize. It's going to go out and call the initialize method of any components that you have registered in your game. So if you have a component that handles AI processing, or you've got a component that handles hitting the high score web service that you created, then it's going to initialize that after it finishes initializing whatever's in the base initialize method. So game components by themselves are not drawable. They're strictly processing. It's strictly update. If you are just doing calculations or you're hitting a service or that sort of thing, you just use game component. If you want to isolate code that actually draws stuff on screen, then you need to use a drawable game component. And the only real difference between the two is that you don't have a draw method in your game component, but you do in the drawable game component. And of course, you still have the update, you still have initialize, and you have the additional draw method in the drawable game component. And those get registered. When you first create your game, you're going to add them to a list of components, and you code them just like you do other parts of your game. You still break everything out into their respective methods. And it's just a way to keep your code nicely organized and include functional areas that make sense to do so. I want to talk a little bit about some of the specific features of the Windows Phone. So these are items that, for the most part, don't exist on the other platforms, with the exception of the audio API. So first up, of course, is the accelerometer. And I actually do have a little demo here, which I'm going to open up right now. And move it over to this screen. So it doesn't do a whole lot of good to show an accelerometer in use over a webinar, because you're not going to really get the benefit of it. But I want to at least look in the code and show you how to set it up within your game and get a good understanding of what's going on. So this is a very simple starting XNA project, and the only thing we've really added, other than a sprite font, is the accelerometer code. And so if you take a look, you're going to see that we've added a couple of classes, or a couple of objects, I guess you could say, to our Game 1 class. We've added a sprite font, which you know about those already, and then the actual accelerometer. And I've created some doubles to store the X, Y, and Z values that the accelerometer is going to return. One thing to remember when you're using the accelerometer in your game, this thing will consume battery life, just like running GPS, just like using the camera. It's a hardware feature, and if you leave it on when you don't need it, then it's going to consume battery life excessively, potentially. So while this is demo code, so not everything in here is necessarily best practice, it's worth showing just so you understand how it works. What we've got here is, in the initialize method, we are instantiating our accelerometer, and we're setting the reading changed event to fire a method anytime a new reading is received from the accelerometer. So if you have a phone and you've got a game with an accelerometer in it, then you probably get the concept. You can move the phone around, and as you alter the X and Y position, and as you tilt it and hold it upright or move it through the air, you're going to get a set of 3 values in three-dimensional space, the X, the Y, and the Z, based on the accelerometer. And so whenever you get a new reading, it's going to fire that reading changed event and then run some code. Now, I'm starting the accelerometer in the initialize method. So that's what this line here is. Typically, you wouldn't necessarily start the accelerometer as soon as your game starts. It's that whole battery life thing. But just for demo purposes, this is where we're starting it. So once we get out of initialize, our accelerometer is running. The only thing I'm doing in load content is I'm just loading up a sprite font to display the values that we get from the accelerometer on the screen. And then in the unload content, we're stopping the accelerometer. Because this is a hardware feature, I know in the past, and I'm not 100% sure this has been corrected, but in previous versions, if you started the accelerometer and then your game crashed or you killed it, you didn't necessarily turn off the accelerometer. So that's kind of a big deal. And again, it's just running and using up energy, but not actually doing anything useful. So do make sure that you stop the accelerometer when you're done with it, rather than assuming that your game will stop it when it ends, because it might not. I think that's been corrected, but I'm not 100% sure on that. So best practice is definitely to stop it when you're done using it. A good example of when you're not using it would be if you pause your game, stop the accelerometer. If you open up an options screen where you're not reliant upon navigating via waving your phone around, stop the accelerometer. Anytime that you don't need it, stop it, because it's using battery. So the update method, not much going on here. We're just looking to see if they hit the back button. That's boilerplate code. The draw method, we've got our Spritebatch, and so I talked about that a little bit before. We got Spritebatch begin. We're passing a bunch of calls. In this case, we're passing in draw string calls, and then we end it. And of course, once we end our Spritebatch, that's when the magic happens and everything gets sent to the video card. In this code here, we're taking the font, which was the Sprite font we created. We're passing in a string, which is X, and then X.toString, formatting it, and then displaying it. And then so we have our positional data here. This is where it's actually showing up on the screen, and then of course the color, so we're displaying it in white. Where these X, Y, and Z values are getting populated is in the reading changed event. Well, actually the new reading event, new reading method technically. But so anytime a new reading is received from the accelerometer, this accelerometer reading changed event is going to fire. And so what it does is it grabs the current reading from the accelerometer, and I'm just sticking it into these three variables, X, Y, and Z. Again, not doing anything super fancy with it. And then once I have the reading, of course the update and draw method are getting called 30 times per second. So I don't necessarily have to explicitly go to draw as soon as I get the reading. I'm going to go to draw either way because it's part of the game loop. And so that event's going to fire, and it's going to stick the readings in the data, and just the next time I get to draw, which is going to be in about 1/30th of a second, then it's going to go, oh, I've got the data, cool, and it's going to display it out. And so you don't have to worry about syncing up, oh, I got readings, hey, I need to display it. You don't have to worry about that. That's handled for you. You just get the readings, store them, and then the next time you go through update, if you care about the readings, then this is where you're going to go, oh, they shifted the x-axis by so many degrees. Well, I need to update the position of my cannon on screen based on the direction they're pointing their phone, or however it is you choose to use the accelerometer. And then, once you're done updating your game state information based on what's returned from the accelerometer, then you're going to take that information and use it to draw something on the screen. And so that's a very simple rundown of the accelerometer. Gestures. Definitely want to talk about gestures. So Windows Phone has support for a number of gestures, and using them in your game is actually super easy. So there's a few things that you have to do up front, and I'm going to go ahead and scroll down. You've seen Spritebatches and Sprite Fonts by now a few times, so I'm not going to explain those again. But in our initialize method, we have something called touchpanel.enabled gestures. So when you're making a game that uses gestures, chances are you're not going to use every single available gesture. I mean, you might, but unless you're doing a demo, you're probably not. So this is where you would specify what gestures you want to support. So maybe I want my game to use the tap and the double tap, and maybe the flick and the hold. So I would just list those items, this one, and this one, and this one, and I separate them with a pipe symbol because this is actually a bitwise enumeration, which means each one of these has a value that is double the one before it. So I could just as easily put touchpanel.enable gestures equals, well, that's a 1 and that's a 2, so I can just put a 3 there. Or if I wanted to include this, that's 1, that's 2, that's 4, so I could put 7, right? But the problem is if you put 7 and then you come back 3 weeks later, you're going to be scratching your head going, 7. All right, that means I probably picked this as this. It's easier just to add the ones you want, separate them with a pipe symbol, and they all get combined, and of course, under the hood it's a 7. But you get the idea. So once you have specified what gestures you want to enable, rather, in your game, then it's a simple matter of going into your update method, checking to see if a gesture is available. Now remember, you're hitting update on the phone at least 30 times a second. So if somebody's doing a gesture it's going to get noticed. If this returns true, if is gesture is available, if that returns true, then you're going to actually read the gesture, and you're going to stick it in a gesture sample object. And then you're going to take a look at the type of the gesture. So this is very simple demo code, but effectively what we have here is we take our gesture object, we look at the type, and then I'm just doing a switch statement. So if it was a double tap, we're going to display this message. And if it was a single tap, we're going to display this message. Now, a couple quick words about gestures. For the most part, they're extremely easy to work with as a developer. Only one of the supported gestures actually supports multi-touch, and that's the pinch. Everything else is a single touch gesture. Now, as a developer, gestures can be a little frustrating because you probably don't have anything other than your phone, and if you don't have a phone, then you're really in trouble, in order to test them. Now, fortunately, on your development machine, if you have a mouse, then you can test most gestures, except for the multi-touch ones like the pinch. I found that notebook touchpads are not ideal, and of course, I think most of them do not have any concept of multi-touch, again, but they do okay. I find the mouse is actually easier to perform a gesture with than the touchpad on a laptop, but your mileage may vary on that. Another thing, because of the fact that we're going through update 30 times per second, sometimes you might perform one gesture in the course of performing a second one, and both of them are going to get picked up. And that's especially true with tap and double tap. So if you're supporting both of those in your game, keep in mind that a tap is when you first touch the screen, or in the case of testing, when you click the mouse, that's also a tap. And then a double tap is if you tap twice within about a 3/4 of a second time span. Well, because you're hitting the update method 30 times per second, there's no way you can double tap fast enough to not register a tap first. It's just not going to happen. So you need to think about what actions you want your gestures to fire. You wouldn't necessarily want to have tap and double tap perform contradictory actions. That would be extremely confusing to your gamers. So let's say you're building a real-time sim where you've got army units that you want to give orders to. Maybe a good scenario here would be a tap selects the unit that you want to give an order to, and a double tap tells him to perform his default order. So tap selects him, that's cool. Double tap says, go do what I told you to do last time. There's no conflict there. And maybe a hold means you're tapping him, that means you selected him, then you hold it, and a little menu can pop up where you can issue a new order. And so again, these are not contradictory actions. They're complementary actions, and so you need to keep that in mind when working with gestures. Some of the other gestures that are supported: free drag, horizontal drag, vertical drag. The last two are probably self-explanatory. Free drag means that you're just moving your finger kind of all over the place. Could be a circle, could be a figure eight, whatever. Horizontal drag is at least the first few pixels of your movement are on a horizontal axis, and so you're going left to right or right to left, and the first few pixels are all it notices. So if you go a 1/4 inch to the left and then 3 inches up, it still thinks that's horizontal. So keep that in mind. And vertical works the same way. It notices the first few pixels. So if you go just a little bit up and then go all the way over across the screen to the right, it still thinks you've gone vertical. So bear that in mind when working with these gestures. And of course, once you take your finger off, the drag complete gesture fires. And so maybe there's a little activity that you need to perform after, if you're doing a drawing program, like a finger painting type deal. Once you lift up that finger, maybe there's some code that needs to fire that says, okay, he's done drawing this line or this box or whatever, so make it persist. And then the pinch, that's your 2-finger gesture. And so that can be moving the 2 touch points closer together or further away. And with all of these, in addition to a gesture type, of course, you also can get information about the location where the gesture was performed. So in the case, I'm going to scroll back up here, in the case of the tap, not only do I know I did a tap, I know where I did a tap. And with the hold, I know where I did the hold. And if with the drags, I know where I started and where I ended. And so that kind of data matters to your game, of course. Then it's available to take advantage of. The last one here is the flick, and that's kind of like a swipe if you have an iPhone. Same basic concept. It's a very brief touch followed by a drag type motion. And so the position property in this case is the piece of information that I'm using to display, well, not to display actually. I'm taking the position of the gesture and I'm sticking it in this variable message pause, which in the draw method is going to be my positional data to tell me where to draw on my screen. So in my little demo, if I tap, then it's going to write the word, that was a tap, wherever I tapped. And if I do a drag, then the little drag message is going to follow. And I don't know how well this is going to do over a webinar, but I will go ahead and fire it up just so you can see it. But if it's a little hard to follow, I'll go ahead and apologize now. Actually, looks like I need to stop my emulator. Hang on one moment. When I have multiple versions of Visual Studio open, and this is something good to know actually, when you have multiple versions of Visual Studio open, if it's the same basic version and it's just multiple instances, I should say, then you're fine. So if I have 3 copies of VS 2010 Ultimate, I'm good to go. But if I have VS 2010 Express and I have VS 2010 Ultimate open, I have found that they have problems both pushing to the emulator. So if I'm switching from one version, not necessarily instance, but one version of Visual Studio to another, then sometimes I have to restart the emulator. So here I'm going to do a tap, and so that was a tap. And now I'm going to do a double tap, and if you watch close, and hopefully you can see this in the webinar, you'll actually see a tap and then a double tap get displayed. So I don't know if y'all saw that, but just for the briefest moment it said that was a tap and then that was a double tap. So let me go ahead and exit out of this. That's it for gestures, and I want to definitely make sure to cover some other stuff as well. And we go ahead and minimize that. Push notifications. We've actually got a whole other webinar that talks about push notifications, but I'll give you the 10-second version here. Push notifications are awesome because you can do a lot of really cool stuff with them. Whether you're writing a game or an app, these allow you to push data to the phone or to somebody else's phone. So maybe you've got a race game and you've got a friends list of other people that play the race game, and even though you're not competing head-to-head in this game, maybe while you're running the race game and you're doing a time trial lap, maybe your best friend is also playing that race game and finished just a little bit before you do. Your game can take their time, their high score, push it up to a service which can then look at everybody that's on their friends list and push that updated time to the phones of everybody that's on the friends list. And you're thinking, well, that's not really a big deal. I don't necessarily want to get a pop-up message with somebody's time every time they do well. But there's more to it. You can take that information as data. It doesn't have to be an actual pop-up message on the phone. You can push a raw notification, and if you're playing the game, when that raw notification comes in, then your game can recognize that piece of data and slap that time trial time up on a billboard. As you're rounding turn 3, you see that your best friend just clocked a better time than you did. And that's without ever leaving the game. That information just comes down to the phone as a result of something that happens externally. And you can do the same thing with apps. Maybe you want to create a weather app that updates the tile on your start screen. So if it's raining, you get a rain cloud, and if it's storming, you get a little lightning bolt or snow. And this can get pushed down and change the actual image on the tile in your start screen without any interaction from you. It just does it as the data changes. You can set it up for how frequently you want to get notifications, the whole bit. And so you have to have your own service in order to pull this off, and then your service talks to the Microsoft Push Notification Service, which then talks to your phone. And yeah, it's way more complicated than that, but I did want to at least mention it. There is a webinar where we talk all about push notifications, so be sure and check that one out. Also want to talk about tasks and choosers, and I have a quick demo for that as well. Let me pull it up here. And so this is another one of those cases where I don't necessarily know that it would translate well over a webinar to see it running, but I do want to look at the code real quick with you. So in this case, we are adding a few extra namespaces to the standard game project. You need to add Microsoft.phone.tasks, which you need to add a reference to the phone DLL over in your Solution Explorer in your references. You're going to add Microsoft.phone. In this case, we're going to add System.io because we're also going to be using some isolated storage to save a picture. And so, like I said, Microsoft.phone.tasks is the other namespace that you need. So just real quick, we'll scroll through here. Standard stuff, Graphics Device Manager, Spritebatch. Here we go. Camera capture task. So this is how you get an image from the camera. And we're going to store that image in something called a texture 2D. The texture 2D is a class that's part of XNA that lets you store a two-dimensional texture, like a bitmap or a PNG or GIF or whatever. When you add these types of images to your project, when you build, it sucks those images in and renders them into something that is more XNA friendly, but you don't really need to worry about what the format is. It handles all that for you. The end result is, in your load content method, you're going to pull up those images and stick them into texture 2Ds. And so that's where the photo is going to go. In addition to the camera capture task, there's something called the photo chooser task. And this allows you to pick stuff out of your library of images on the phone. So when you fire up the camera capture task, it's going to grab an image and it's going to save it to your phone. And then you can use the photo chooser task to either grab an image from the camera or grab an image from your film roll, so to speak, your photo album. And then I've also got another task in here which isn't directly related to camera stuff at all, but it's worth showing just as an example, is the email address chooser task. And then a string, of course, to store the email address. So we'll scroll down here. In the initialize method, I'm setting some gestures. We're going to use the hold and the double tap. In our load content, we initialize our camera capture task, and we're setting some events. So again, here's a case where, while you don't necessarily have your traditional click events and form load events like you do in Windows or web programming, there are some events that you need to listen for. And so one of those is the completed event for your camera. And so we're going to create a method called camera completed. Photo chooser task, same thing. Once that's completed, there's a method that's going to fire. And then for our email address chooser task, we're doing the same thing when that's completed. And so I'm going to skip the email one for now because I definitely want to talk about the photo stuff. So once photo chooser is completed, assuming that you've actually chosen something, so it's not null, then you're going to stream that image into a texture 2D and stick it in the selected photo variable, which is a texture 2D. So that's important to remember. You're using your graphics device, you're taking the chosen photo that was selected in the chooser and you're streaming that into a texture 2D. Camera completed works effectively the same way. Cool thing here is that you don't necessarily need to worry about how the camera works or a lot of the guts and concepts behind camera. All you really care about is, I'm going to use the camera instead of the photo chooser, and I'm going to take a picture, and I don't really care how because the camera handles that. I push the button on the camera and it takes a picture. You don't need to worry about the details. And then you're going to take that image and you're going to stream it into a texture 2D. And at that point, it's ready to use just like any other image that you've loaded up in your game, whether you loaded it during the load content method or whatever. You've got a texture 2D in memory that you can use. And so that is your selected photo. And you'll notice that we're using selected photo regardless of whether they use the chooser or the camera, because that's a good user experience is when you need to provide a picture for something, you give them the choice. Do I want to take a new picture, or do I want to use a picture I already had? And so you give them that choice, and then regardless of which one they pick or how they get it, it all ends up in the same place, which in this case is our selected photo. And then here we've got a little bit of additional information because we're not choosing a photo. Remember, this is the camera one. We're not choosing a photo. We're taking a photo. And so one of the things we need to do, if we want, is we can add it to our media library and provide a lot of information about when it was taken and some other metadata. But we don't have to do this. We can just as easily capture that image and dump it into the variable in memory and use it in the game without ever actually saving it to the media library. That's your choice as a developer whether or not you want to implement that. And so you provide some metadata, you save picture, and then you close the stream. And then in our update method, we're looking at the gestures that are performed, and oh, if we touch, then we're going to show the camera. And if we do a hold, then instead of the camera, we're going to do the photo chooser. And I've got some other code that's commented out here just because I was working specifically with the camera stuff. But basically, here's your email compose task right here, and it's pretty simple. You just create a new task. You pass in a little bit of information, the body of the email, any carbon copy addresses, who it's to, the subject, and then you can show it, and then you can send it. And then SMS texts, which I actually don't have instantiated up above, but work very similarly. You create a new compose task to send somebody a text message. You provide information, what's the body of the message, who's it to, then you show it, and then when you show it, you're actually showing a dialogue on the phone that gives the user the option to hit send or not. So you don't fire it off at that point. You prepare it, you compose it, and then you present it to the user, and then they actually have to submit it or send it. So that way you're not firing off emails behind the scenes that they don't know about, and that's a good thing. And then in our draw method, we're just taking the selected photo, which is the texture 2D, and calling the draw method of our sprite batch to show it on screen. And I'm going to go ahead and close this one up because I don't think it's going to look that good in the webinar, especially since I'm running on a laptop and not using a camera, but I think you get the idea. And of course, if there's any questions, feel free to ask. I'm happy to go over stuff, and my email address is on the slides as well. So isolated storage, real quick, I want to talk a little bit about that. I don't actually have a demo prepared for it, but I can definitely talk about it. So the isolated storage is, the concept is that you can't write stuff anywhere you want in the file system. So every app has their own isolated storage area. And to use that, you're going to set a reference to the isolated storage namespace, which is under System.io. And it's just a couple lines of code. You're going to create an isolated storage file, and then you can pass, just like writing a file like you would in Windows, you're going to write the file to isolated storage, and then you can read that back. And good examples of where this would be used, as I mentioned before, is stuff like persisting the game state when your game gets suspended, or maybe you just want to store some data. Now, as a developer, this is important. When you're working with the emulator, every time you turn off the emulator, isolated storage goes bye-bye. It does not persist in between runs of the emulator. Now, as long as you keep your emulator open, then of course you can update and read and send stuff to isolated storage, no problem. Even from one project to the next, you can, now of course each app is going to have its own isolated storage, but you can send from multiple Visual Studios just leaving the emulator open. But if you close the emulator and then start it back up, it's like getting a brand new phone. It's wiped clean. So just keep that in mind. If you think your stuff's not working right, it may be because of that, and it turns out your code's fine. The last thing to mention, the audio API is not specifically a phone feature, but it's worth mentioning if you're used to doing XNA in Windows or the Xbox and you were using a tool called Exact, Exact is not supported on Windows Phone, and so you have to use the API. And the API is designed to make things really easy. You've got some classes in there like sound effect, which is used for firing off instances of specific sound effects like a gunshot or an explosion. And then you have your media player, which plays say background music, soundtracks, that sort of thing. Real quick, I want to talk about some resources here. Some excellent educational resources are on the Create site. You've got starter kits. Here's an example of the RPG starter kit. You've got labs. So unlike starter kits, which are the complete code that you just download and run, labs allow you to build it yourself step by step and then walk you through building the game from beginning to end. You learn a lot. And of course, any assets that are part of it are free for you to use however you choose. Code samples. So there's a ton of code samples in the education catalog. And this is stuff like, how do I do isolated storage? How do I do gestures? How do I play a sound effect? Lots of really great information. Articles. There are a lot of articles with new ones literally coming every day. Here's a small list of some of the examples. Articles covering best practices, what's new in Mango, Visual Basic support. Definitely worth a good read. Tutorials. There's a lot of tutorials. Some of them are articles, some of them are labs, and these walk you through, again, the process of building a game or an app for your phone. So excellent resource, well worth checking out. And I think now it's time for questions. Looks like we've got a few in here. Will source code be available for some of these examples? Certainly. I can either post them up in my blog, or I can talk to DevExpress and make sure they're made available somehow. Are the camera task choosers going to change with the Mango update? I do not know. I actually haven't dug into Mango a whole lot yet. It's on my list of stuff to do. As far as I know, I think there will be some new functionality certainly, but I think the camera stuff, for the most part, I don't think it's changing much. But I'm not 100% sure on that. Will we have access to the demo projects Chris has shown us? Yes, yes. I will make sure they're available somehow. Or a recording of the presentation. Again, yes, all of these are recorded, and there will be a link posted. If you go to the DevExpress website and click webinars, there's a tab for past presentations, and if you click on that, then it shows all of the webinars that have already been completed, and it may take a day or so for it to show up, but it definitely will be there. Next question, is the draw and update iteration in an XNA game something asynchronous so that there is a typical need for synchronization for common data access? No, not as such. So when you're running your game, you've got your loop, and it's going to make those calls for update draw over and over and over and over, regardless of anything else that's going on in your game. And so what happens is, because those calls are being made 30 times per second in most cases, your data, you don't need to synchronize, because what's going to happen is if you go out and fetch some data, whether it's because you get an event that says that you've received a push notification, or you get an event because your accelerometer has sent you some data, or you get an event from your GPS sensor, you're going to take that data, because that event's going to fire a method, and that method is going to stick that data somewhere. And then the next time update gets called, which again is getting called 30 times a second, the next time update gets called, you're going to have code in there to look and see if you have data. And if you do, you're going to use it. And if you don't, then you're just going to keep on going. So you don't necessarily have to manually synchronize anything. Let's see. When do we publish applications in games, and where? Okay, so apps and games are published to the marketplace. I did cover that some in the first webinar, although I do believe it'll also get covered in a later webinar. And of course, if you're looking for more specific information on that process, the best thing to do is to go to create.ms. I cannot talk today. Go to create.msdn.com, and that's how you get to the marketplace. And there's also a lot of really good information there about how to publish. But we definitely will talk about it more. Will we have support to create games in Unity 3D? You're asking the wrong one about that. That's definitely a question for Microsoft. I'm guessing that at this point it is not on the roadmap until Unity 3D supports XNA. I don't know if it does. I'm actually not a big 3D guy. I mean, I like playing them, don't like making them. So your best bet for that would probably be to hit their website, Unity's website, and see if they support XNA or Silverlight, and if they do, if they have any kind of roadmap for Windows Phone support. Because chances are, if it is going to get implemented, it's going to be by them, not necessarily by Microsoft. But that's speculation on my part, and that's bad. Could you do some simple example also? Not sure what you're looking for. So the first webinar actually does cover the starting XNA project, so that's definitely worth watching. We go in depth with everything that's in that starting project, so that's worth checking out. How do we ensure the lock screen doesn't shut down the game for Accelerometer only games? I don't know. That's actually a great question and definitely something people should know. I would have to Bing it or Google it, and I'm more than happy to do so and post an answer on my blog. It's just not something that I've run into. Not so long ago, next question, not so long ago, I saw that Accelerometer can be tested within the emulator, and what about camera? So the answer to both of those is yes. You can test the accelerometer in the emulator, but you're only going to get some fixed coordinate values. Basically, you don't get a Z, as I understand. You get an X and a Y based on how you rotate the emulator, or you can provide a data file with some fudged values as part of your project and then read those in. So not necessarily an ideal solution, but when you're dealing with the emulator, that's probably the best you can hope for. The camera, yeah. So if you use the camera in the emulator, what you actually get is a little white box that shows up on the screen, and it moves around, and then when you hit the take picture button, it actually just grabs wherever that little white box is and generates an image out of it. So it's not using like the camera on your laptop, for example, or your webcam or anything like that. I don't think there is support for using an external camera in the emulator. I certainly haven't tried that, but just from what little bit I've played with it, I never saw any capability to use an external camera like that. It just simulates a camera. Let's see, is it possible to use XNA as a part order control of a Silverlight Expression Blend project as a special display of a remote? Well, I'm not entirely sure I understand what you're asking, but there is definitely going to be support in Mango for hybrid projects that are Silverlight XNA blends. I said blend. I shouldn't say that because that's confusing. There are going to be hybrid projects where you're allowed to use XNA within Silverlight, but I don't know if that specifically answers your question. Next question, are Xbox avatars supported? That is a very interesting question. The official answer is yes, but it requires access to some specific APIs that Microsoft has not made publicly available. So if you want access to Xbox Live functionality, and so this is kind of the Windows Phone equivalent of the difference on the Xbox between Xbox Live Indie Games and Xbox Live Arcade. So there was some stuff that you could do in Arcade that you couldn't do in indie games, but you had to have a special relationship with Microsoft, either a publishing contract or you had to be a game publisher in order to get access to the arcade stuff. It's kind of the same way on the phone, right? So yes, avatars are supported, but not everybody can get to it. And there's actually stuff like achievements, avatars, there's a couple other things that there is an API for it, but you and I don't necessarily have access to it. We would need to submit our game idea to Microsoft, and then they would go, hey, that's a great idea, we're going to steal it. I'm just kidding. I didn't say that. They'll say either, hey, that's a great idea, why don't you go make that, and here we'll give you access to those APIs, or they'll maybe say, that's not really what we're looking for, but yeah, you have to work with Microsoft in some capacity to get access to the Xbox Live functionality. Are there any other questions? I think that may be it.
Yeah, Chris, I think we've answered, or you answered, all the questions that I currently see.
Great. I will be happy to answer any questions that come in through my blog or through my Gmail account. So if I didn't cover something in here and you'd like to see it in a future webinar, or maybe I just didn't cover it quite deep enough for what you need, feel free to drop me an email or hit me up on Twitter, and I'll definitely try to answer it.
Awesome. Thank you so much, Chris. All right, so Chris's next webinar, his third webinar, is coming up next Thursday, June 23rd, and it's a deeper dive into Silverlight on Windows Phone. Right, Chris?
Yes.
Okay, awesome. All right, so some exciting news. DevExpress just released version 2011 Volume 1 last week. Our latest release just came out. If you haven't already, visit our homepage, devexpress.com, and download it and let us know what you think. We also have more webinars coming up all through the month of June and July. You can check them out and register, including Chris's, at devexpress.com/webinars. And again, if you missed anything from this webinar or you'd like to review any of our previous webinars, you can visit us on the DevExpress channel at tv.devexpress.com. And if you can't access that, you can also visit our YouTube channel, youtube.com/DevExpress. All right, thank you so much again to Chris. Thank you all for joining us, and thanks for choosing DevExpress.